Okay, so for our first problem, I gave everybody this, and then I said, figure out everything you know about it. So the first thing you had to do is multiply it out. But did you really have to multiply it all the way out? No, because all we really care about is this first one. You should have got 2x to the third. Now, after that, would I like you to be able to multiply it out? Yeah, and there could be a question like that on the test. But this is the lead term. That's the boss, and it tells us everything. All right. So Jack Lewinsky, tell me one thing you know about it. Just because it has a 2x to the third is the lead term, what else do you know? Nice. Lead co, and it tells us stuff. The lead coefficient is 2. Javon, tell me something you know about my polynomial then. Very good. Degree is 3. Okay. Next up, Vikram, tell me something you know about this. On the right, it's going to be up. Tell me why you knew that it would be up on the right. Because the leading coefficient is positive. Very good. Now, how about the left side? Tommy Rodebach, could you know if this is going to be the same or different on the left side?
Would it be the same?
It would not be the same because this is odd. An odd kind of is supposed to be a word that makes you think, oh, odd is like different. And so it's different than up and therefore down. Thank you for trying, though. So look at the degree next time. See if it's odd. And if it's odd, you make it different on the other side. All right. So what else do we have to know? Well, we're graphing today. And so here's the stuff you have to know. A constant function, like y equals 3, that is called a constant function. Why? Because there's no variable. It's just y equals 3, not even 3x. Y equals like 3x, or maybe I'll keep it even simpler, not 3x. Let's just keep it y equals x plus 3. See, this one has a degree of 1. Degree of 1, only a 1 power. And look how it's straight, but it's tilted. This one's got a degree of 2. That's like y equals x squared, and I know it's shifted down a little bit, so I'm going to say like minus 2. Do you get that one's got a curve? We went from flat to tilted to a curve, and now degree 3, that's what you guys are just starting to do, is graph things that are more like this. That's what polynomials do. They get curvy. So that one might be like y equals x to the third plus 3x squared plus x, something like that. Now let me see if that could actually be right. This one's odd, which means they have to be different on each end. This one's different on each end. And it's positive in front, so when it's going up on the right. Actually, that could be the answer for my equation. How about degree 4? Well, then I have to write something that's got like x to the 4th. Yeah. And degree 4 means that the biggest term would be x to the 4th. And then maybe it's got like a plus 3x squared plus 2x plus 6. Do you get how this one's got a lead coefficient that's positive and it's going up on the right? It's even, so they're both going the same way. Even degree means that they go the same way. Both of them are up. And then degree 5, they start getting even crazier looking. Right ends up, so I'd have to have a positive lead term, like 2. X to the degree 5, 5th. And then like plus 4x to the 3rd. You could have a 5x to the 4th in there. You have a whole bunch of other stuff that, like I said before, it doesn't matter that much. And then the very last number like what you add at the very end, that's called the constant. And that's the y-intercept. I've never told you that before, but it is. So if I put a plus 0, it's because it goes through 0. This one was plus 6, it's because it goes through 6. The very last number is called the y-intercept. All right. Quartic is what a degree 4 is. Quintic is what a degree 5 is. We're not going to test you on those names, don't worry. Okay. If it's got an even degree, a positive leading coefficient, if it's got an odd degree, negative lead coefficient, what am I supposed to do in here? Oh, the end behavior. So each one of these needs a little right, left. So would you put that in the first one? Put a little right and a left in there, an R and an L. All right, so if it's even degree, then it's going to be the same on both sides. I'm just going to write same up here because that's what that means. Every time you have an even degree, they're going to be the same on both sides. Odd degree, they're going to be different. If it's got a positive leading coefficient, actually, I shouldn't mess you up by putting right on the left. I should say left on the left and then right on the right. So if you copied me exactly, I'd change it to left then right. Positive lead coefficient, that tells us the right side is up. How do we get the left side? I know somebody's thinking it. How do we get the left side? Can you do it? I was looking at the whole class, but yeah, I'm looking at you now. How do you get the left side on that one? Then it's got to be the same. So if it's going to be the same, up, up and up. Left, right. Lily Studensky, I'm right in here. I'm circling it in green. It says it's got a negative leading coefficient. That tells you one of them. Boom, right away. Right side has to be down. Very good. Now tell me the other one. Because why? You got it. Down, down. Okay. Left, right. Dylan Nault, tell me how to figure out this one. The right side is up. Tell me how you knew the right side was up. Because of a positive leading coefficient, this has to be up. And then how about the other one? You said down. Why? Because it's an odd degree, and that forces them to be different than each other. Very nice. All right. Left, right. We're on the last melon. Luke Scrivseth. What should I do first, the left or the right, Luke?
You want to do the right.
And tell me how you do the right.
Down to negative leading coefficient.
So it's down. You are correct. Down on the right. Now what?
Down the left is odd degree.
Odd degree means it should be different, not down. It should be different. As soon as you said odd degree, I heard you say odd degree down. You should have said odd degree. It should be different. It should be up. Okay. This kind. Find the leading term of the polynomial. Quinn Wested, can you tell me the leading term of this one? 2x, x, and x. 2x to the third. Very nice. And now, do I have to actually multiply the rest out? No, you don't. It's just that first one. It's really nice that way. Amelia, can you tell me the left and the right?
I saw that the right was up.
Correct. Why?
Because the
Leading coefficient.
was positive
Very nice.
and the left was down
Because the degree was odd, you knew it had to be different than this one, so you made it down. Very nice. Okay. So, what if there are exponents on factors? I did tell you this a little bit yesterday. Let's see if anybody caught it. Tell me on this one, what's the lead term? Please don't say x squared. Lily is correct. It is x to the third. How did you get that? So that squared goes on that x. And then how do you get the 3? Isn't that just 2? Yep, then there's another x there. Put it all together, you got x to the third. What if there's no number? Then there's a 1. Make that a normal 1. 1 times x to the third. There's my lead term, which tells me everything. Okay, so let's actually do one. Act like this is on the test. Everybody try to answer this one. All we really need is left and right. But you better figure out the lead term. You don't figure out the lead term, you won't get the left-right correct. This is the part where as you work on this one, I'm going to take attendance. Just say here when I call your name. Natalie, Matilda, Alban, Amelia, Angelina, Bertha, and Joe, Veda, Jack, Martina, Javon, Vikram, Dylan, Ella Paulson, John Piper, Tommy Radebach, Nick Richards, Elisa. In the room, Elise? Yep, you are. Okay, Victoria. Is that an online here?
Yeah.
Okay, thank you. Luke Scripseth.
Yeah.
Alex Stone. Last call for Alex Stone. There's almost always somebody absent. Lily Studensky. And Dallin Thomas. Cameron Thompson. Quinn Wested. Bennett Worry. All right. Only absence today, Alex Stone. Real quick, just put that in. Okay, I hope that you looked at these. This and this and this, and put it all together and got 3x to the third. Then I hope you thought, okay, this is positive, and that's supposed to tell me something. Oh yeah, it tells me the end, which is the right side, is up. Raise your virtual or real hand if you had right side up. Okay, good. Now harder, left side. Really? Should come down to same or different. Is it the same or different than up? It's different. Victoria, can you explain why it should be different than up?
That's because it's a -3.
But there isn't a -3. I know what you're seeing, but that's not the lead term. See, in our lead right here, there's no negatives. So it's not different because of that. It's different because this is odd. Because the degree odd means different. That's why it's different. So it's not up, it's obviously, if it's different, it's got to be down. Okay. Everybody try one more. That one, figure out its lead term, figure out its left and its right. Always do the right side first. Bennett, worry. I'm going to highlight some stuff. Did I highlight everything I needed to, Bennett?
No.
What did I miss?
2.
Some probably forgot that. Like I just sort of acted like I forgot it. All right. So then if I put those all together, Bennett, what's the lead term?
2.
Very nice. Now, does that tell you anything about the right end? You are correct. Why? Nice. Perfect. All right. I'll have Dylan Nault take over next. The left side should be the same or different than that? Why? It's different because this is odd. You are correct, sir. Final answer? Down. All right, cool. Now, this is like a challenge one. I actually am curious if any of you can pull it off. It's got the little video game meme of what the scary monsters looked like in each year up to 2014, but kind of that was a long time ago. Guys, remember me telling you guys about cryptocurrencies? So I hope somebody at least was able to go the x, oops, I'm trying to use a highlighter here. The x squared, the 2x squared to the third, the negative 5x to the fourth, you put them all together. I'm going to do each one separate. This one's x squared. Oh, that's too light. I'm going to try drawing in green. That's a lot easier to read on a black background. X squared. This one would be, I bet a lot of people messed this up, 8x to the 6th. You multiply like this. I bet a lot of people didn't know that, and I understand. And then this is negative 5x to the 4th. Put it all together. 5 times 8 is 40, and it's negative 40. Look at, I just did the numbers first. Now I'm just going to do the x's. X squared, x to the 6th, x to the 4th. On this kind, you add. That's x to the 12th. Did anybody beat the boss level? Put your real hand up. Oh, we got 1, 2, 3, 4. Anybody online catch that one? All right, so if we had graphed this, it would be down on the right. Joey, can you tell me why it would be down on the right? It's a negative on the lead what? Coefficient. Very good. Then would the other side be the same or different than that? Elisa, would the other side be the same or different? It'd be the same. Why? Not because it's positive. Even. There you go. She quickly changed it to even, and that is correct. All right. Cool. Is there anything else you have to know? Yup. Last thing. I think you're going to be ready for the test. I'm not saying I'm giving you the test on Monday. I'm not. But like you, after this last thing I teach you, you'll have learned everything. So here's the last thing. Zoom in on this one, everybody. Imagine you had to graph this. You'd go like this. X minus 2 equals 0. So x has to equal 2. Remember, these are called the zeros. They make this equation equal 0. If I stick a 2 right there, it'll make it equal 0. That's what they're called. They're called zeros. They're also the X-intercepts. So when it says x equals 2, can put a dot right there. The other one, x plus 3 equals 0. So x equals negative 3. Negative 3 is a 0. That means I put it right here. Dot. And now, remember that lead term thing we just did for like 20 minutes? It's just x squared in this case. That's the lead term. It's got a positive 1 in front, so its right side is up. It's even, so they're the same. And then I can draw my picture. There, I graphed it. One thing I left off was the vertex, but we're not too worried about the vertex right now. If we wanted to, we could find the vertex with some other strategies. But for right now, we just want to kind of generally know what it looks like. And it's a U shape, goes through these 2 dots. What's the new part, Surver? These 2 dots. The fact that it goes through 2 and negative 3. I'm sorry, but my iPad has stopped responding. I can't type stuff. I'm going to try plugging my Apple Pencil in here to see if it will repair again. It was paired a second ago. Come on. Okay, please work. Yes, it worked. Okay, so this one. Can you do this? X is negative 1. X is 2. X is negative 5. Do you see what I just did there? I just figured out what would make it equal 0. If I put a negative 5 here, it would make it equal 0. If I put a 2 here, it would make it equal 0. And if I put a negative 1 here, it would make it equal 0. So those 3 spots, negative 1, 2, and negative 5, those are the 3 spots. Now, what if I told you it went up on the right? Think about it. X, 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 that's 1x to the third. It's going to go up on the right because it's positive in front. What if I told you it went down on the left? Amelia, would you agree that it goes down on the left?
Yes.
How would you know?
Because the degree is odd, so it's going to be different.
This is odd, and therefore it's got to be different than the other end, so it must be going down on the left. Could you connect the dots? Do. Could you have done that? I don't think it's that hard. If you know it has to be down on the left and up on the right, and it goes through those 3 dots, it's not that bad. All right. Now this one, easy, oh my gosh, and then easy. The oh my gosh part, just set 2x minus 3 equals 0. And it'll be a fraction, and don't freak out. It's just a little fraction. It's just like a decimal. You'll figure out that x is some little decimal. It's between a couple spots. Try this one. This is the kind you'd need to be able to do to get an A. You're going to get 3 roots, 3 dots. I'm putting them in the wrong place on purpose. And then it's going to probably look like this, sort of. And you're done. Okay? Figure out where the 3 dots go. Figure out if it's up on the right or down on the left, or up on the left or down on the right. Okay, you should have said x equals 7. 2x equals 3, so x equals 3 over 2. If you don't like that, you could say x equals 1.5. And the third one, x equals negative 9. I put dots at negative 9, 7, and 1.5, right in between 1 and 2. Should it be going up on the right or down on the right? Up, because the lead what is what? Yes. So the lead term or lead coefficient, you could say it either way, is positive. It's 2x to the third, and that's positive. So it's up on the right. How about on the left, Bertha?
Yeah.
Why?
Because
This is odd, means different. If it's different than up, it must be down. Once you know that, you should all be able to connect this and make a nice little wave. Put your hand up if you feel like you got this. Okay, Alana, you're already done. I'm just behind. Good job. Do. There you go. That's how you graph them. It's not that hard, is it? Just find the places it touches. Figure out if it's going up or down on the left or the right. And then you draw a line through it. Okay. So we've already talked about all this stuff. So this is all discretely review. And I'm just going to do one last one for you where there's a negative in it. Not asking you to do it. I'm asking you to watch me and be ready when I call on you to do something. Why am I highlighting those? Jack, why did I highlight those? Very nice. You said it perfectly. Because combined, they make the lead term. Negative 2x to the third. That tells me it's going down on the right. It tells me all kinds of things. Okay, so I guess I'll put those in. Left, right. And if it's on the right, it would be down because it's negative. Elisa, do you feel like the left side would be the same or different than that? Why? All right, it is different. So instead of down, we use up because that is an odd degree. Okay, and last, the X-intercepts. X equals, Javon, can you do this one? X equals what? Correct. Bertha, can you do the hard one? I think you can. Tell me what to do for the harder one. Put the equation equal to 0, correct. Minus 3, negative 2x equals negative 3. Now what? So negative 3 over negative 2 becomes 3 over 2. Yay. What's that the same as? 1.5. Very nice. 1.5 goes right there. Negative 3 goes right there. And I have one more root. Bertha, you want to just finish it off? What's this middle one? Positive 1. I put a dot there. Oh, they're really close to each other. That's annoying. But we can do it. Final answer. It has to be going up on the right, so I'm going to go this way. Down. Up through this one. Back down again. Crap. It's supposed to be down on the right. So I did that one wrong. I'm going to erase my answer. It's going to happen to you, so don't laugh at me. And it's supposed to be down on the right, so I'm going to go like this. There we go. Okay. That's about as hard as it gets. So, you learned some heavy duty stuff Friday, and now you get to see what you really look like your whole life. You've been looking in the mirror, and it's been telling you lies about how you look. All right, there's a worksheet. Could somebody look in before I can get there and tell me what the name of it is? Like U this and L that. U10L4 is the worksheet. I'm going to open it and I'm going to tell you which problems you can skip, because I'm a believer that it's not really right for a teacher to just assign you whatever's on the page, because sometimes you don't need all of that extra practice, and I don't want to waste your time. And this will make it more doable, and I believe more kids will do their homework when you keep the homework small and doable. So I'm going to see if I can just assign a subset of the problems. And okay, I usually assign number 1 just because it's usually pretty easy, good way to start, you know, not too hard. And I always, some kids already start the homework before I get there, so I don't want to hurt them by like not doing 1. So we will skip 2, and we will skip 4, and we will skip 6. That's the same as saying do the odds. I'm assigning you the odds. You can do the odds, and you can even skip the even numbers. That's the same exact thing, Mr. Surver. Yeah, okay. All right. So on that very first one, let's make sure that you get started right, because my dad always said if you got started on something, you were halfway done. I'm going to highlight some stuff. That and that, and that and that. That's a pretty rough one. I really wish they would have given us a simpler one for our first problem, but I didn't make this worksheet. But I think you can hang with it. That's x to the 6th, and 2 to the 3rd is 8x to the 3rd. Then when I put them together, it's 8x to the what? Say it if you know it. Yes, 8x to the 9. That's my lead term. Now I got to just figure out the degree, leading coefficient, and behavior. All this stuff's easy now. I mean, this number is something, this number is something. Because this is positive, it's up on the right. Because this is odd, it's down on the left. And so, yeah. The hard part is getting the 8x to the 9th. Did you guys catch this? This was x to the 6th because we multiply on this kind. And this was an 8, not a 2, because we do 2 to the 3rd. All right, that's the tricky part. Then you got a graphing one on number 3. And if you want extra practice, you know, like there's some kids who really want an A on this next test. Do you get it wouldn't kill you to go do the evens? It's not like it's illegal. Just saying you don't have to, but you could. You want an extra practice problem. Okay, that's all I got for you for the video for today.